In this video, we're going to do some graphing examples, and we're going to talk about something called a slant asymptote as well. So we're going to start just by graphing. We're going to find the things that we typically find. So we want to look for where are our asymptotes and holes. So let's start with horizontal asymptote. So here my degrees are the same. So I have 1 divided by 1. So that is our horizontal asymptote. Vertical asymptote, what makes the denominator equal 0? No common factors. So there is our vertical asymptote and no holes. Okay, the other thing that we want to find is the intercept. So we did this a little bit before, but x-intercepts, we're going to set the numerator equal to 0. So x equals -5, so that means we have an x-intercept at -5, 0. We're also going to find what is f of 0. This is to get our y-intercept. And we plug in 0 for every single x. So 5/2 or 2.5. So my y-intercept is going to be at 0, 2.5. Okay, so we're going to graph these things. So how we put asymptotes in is just with a dotted line. So we have a horizontal one at y equals 1. And I'm actually going to grab a pen, you guys, just so this is easier to see. Okay, so we have a horizontal asymptote at y equals 1. And we have a vertical asymptote at x equals -2. So anytime you get this kind of like cross with your asymptotes, my graph is either going to be here and here. Sorry, my graph is either going to be here and here, or here and here. It kind of like hugs the asymptotes and it's opposite of each other. So what's going to help me is those intercepts. So -5, 0. Sorry, 1, 2, 3, 4, 5. So that means this part of the graph is going to hug this way. Now, I could always plug in other x values to verify that, but I'm just letting you guys know that that's not necessary. So it's always going to hug those asymptotes. It's going to get really close to either side. So my other one should be up here, 0, 2.5. So this one, same thing. It's going to hug those two asymptotes. Okay, if you need to plug in additional points to verify, that's fine, but usually my asymptotes are enough to say which way it's going to go. So the other thing we're going to be asked about with our graph is the domain and range. So things I need to consider for domain are the values that x could not be. So for this one, x could not equal -2. So if I wrote that in interval notation, that's what you're going to be asked to do today is -∞ up to -2. And then -2 to +∞. The range is affected by the horizontal asymptote. So here I can see my horizontal asymptote is not going to be crossed in this case. So I have values from -∞ up to 1, and then 1 to infinity. Okay, this next example, you guys are going to see a possible where the horizontal asymptote might be crossed. If I get this t with asymptotes, my horizontal asymptote is not going to be crossed. Okay, here we're going to see a different example. Okay, so this is factored, but my degree on top is 2. If I were to multiply those, my degree on the bottom is also 2. So my leading coefficient is 2 and 1. Okay, my vertical asymptote, I'm going to have one at 0 and at -4. Those two values would make my denominator 0, and they're not holes. I don't have any holes because there are no common factors. X-intercept, so set my numerator equal to 0. Remember, if you have a constant in front, like this 2, that doesn't affect it at all. I could divide everything by 2. So my zeros are going to be -1 and 3. So the points -1, 0, and 3, 0. Y-intercept, plug in 0. For every x. Okay, so now what we're going to notice, I've got 2 times 1 times -3 times 0 times 4. On the bottom, I have 0 times 4, which is 0. So I'm going to get -6 divided by 0. That's undefined. So if you get something like that, that just means no y-intercept. Okay, it's never going to cross the y-axis, which actually makes sense because the y-axis was one of our vertical asymptotes. right? So if that's a vertical asymptote that can never be crossed, it makes sense that I'm not gonna have a point then on my y-axis. Or sorry, yep, that's right. Okay, so let's go ahead and graph here. Okay, so this is a scenario, guys, anytime I have two vertical asymptotes, so we've got 0 is a vertical asymptote, and I have -4. And then I've got a horizontal asymptote at 2. Okay, so we kind of have like 3 sections. I've got this middle section and then this left section, right section. So same thing up here. I'm either going to have like here or here, or I'm going to have values here or here. The middle can do a lot of different things. It can look like a mini parabola, or it can look like a mini cubic. It can cross the horizontal asymptote in the middle. So I'm going to plot my x-intercepts. So I've got -1, -1, 0, and 3, 0. Okay, so over here, this one is going to do this. It's going to hug here. Now the middle, I don't know for sure what this is going to do. It could do this, or it could cross. So I need to pick another point in here to find out. I also don't have any points on this left side, so it's either going to be down here or up here. So I need to plug in some points to find. So I'm going to use my original equation, and I'm going to plug in some values for x, okay? So let's see, I need something here in the middle. So let's maybe plug in, let's plug in 0.5 and -2. So I want to find, what is it doing here? Is it going up or is it going down? I'm not really sure. So, or maybe I want to do 3. So I want to find f of 0.5, and I want to find f of -3. I also want to know what is it doing on this left side. So this is -4, so I'm just going to pick -5. Okay, so we want to find these. So what I'm going to do is I'm going to use my calculator to help with this, but I'm going to use the original function, and I'm going to plug in those values for x. So I'm going to do 0.5 first. All right, so we're plugging in 0.5 for x. So I'm going to do 2 times 0.5 plus 1 times 0.5 minus 3, okay? And then divided by 0.5, guess I'll put that in its own set, 0.5 plus 4. Okay, so -67.5. Okay, so 0.5 is at -67.5. So that means it's way down here off the graph. So it's going to get really close to that vertical asymptote on this side is what that means. So it's shooting straight down in order to make that happen. Okay, so now I wanted to know what's going to happen at -3. So now I'm putting in -3 for all of those. So I've got 2 times, sorry, I used my equation up above again. So we've got -3 plus 1 times -3 minus 3 divided by -3 times -3 plus 4. And I got -8. So at -3, we had a value down here at -8. 1, 2, 3, 4, 5, 6, 7, 8. So this one is kind of doing like a mini parabola. So this one, it didn't cross up here, but it can sometimes. So this is that situation where I might see something like this, and so that's why I had to test that point. Okay, so now I need to know what's it doing on the left. Is it going to be here or here? So now I'm going to do -5. So I'm putting in -5 for every single one. So we've got 2 times -5 plus 1 times -5 minus 3 divided by -5 times -5 plus 4. $12.8. So at -5, So -5 is right here. We're up at 12.8, which is up here. So that means it's going to do something like this. Okay, so that's why it's important for us to plug in values when I don't get enough from the intercepts. Okay, so now let's go ahead and find the domain and range. So the domain, if I look at my graph, I have values everywhere except for my vertical asymptotes. So my vertical asymptotes are at -4 and 0. So we have -infinity up to -4 is fine. Then between -4 and 0. And then from 0 to infinity. The range, I actually never crossed my horizontal axis. So this, I would just say then -infinity up to 2 was, I have y values. And then from 2 to infinity. If it did end up crossing at some point, you guys, I would just say the range is all real numbers because I have values everywhere. In this case, it never crosses, so we are just excluding that y value that we don't ever see. All right, last one here. We have, now I mentioned we're going to talk about slant asymptotes. So here I'm going to find those same pieces. I'm going to factor my numerator real quick. So numbers that multiply to be -6 that add up to be -1. Okay, so horizontal asymptote, my degree on top is bigger, so there's no horizontal asymptote. Vertical asymptote is going to be at x equals -1. No holes. X-intercepts, I'm going to have 3, 0 and -2, 0. Setting my numerator equal to 0. Y-intercepts, plug in 0 for all the x's. So let's see, we get -3 times 2 over 1. So -6. All right, okay. So when the degree of P of x is 1 more than that of Q of x, and there are no common factors, then there is what we call a slant asymptote. So it won't have a horizontal asymptote because the degree on top is bigger, but if it's 1 more, we have what's called a slant asymptote. So how do we find this slant asymptote? We are going to use long division, and we're going to actually do that operation here. So I'm going to write out. Okay, so that is, I'm taking my numerator, dividing by my denominator. This is where I'm looking at what do I multiply x by to equal x squared? I'd multiply by x. Then I take this and I multiply it by this. So x times x is x squared. X times 1 is 1. Now, the 1x. Okay, so then remember this is draw the line, change the sign. So these are both positive. I'm going to make them negative. So when I combine here, those are going to cancel, and I'm going to be left with now -2x, and then bring down that -6. Now I repeat. What do I have to multiply x by to equal -2x? We have to multiply it by x minus 2. -2 times x, -2x. -2 times 1 is -2. Draw the line, change the sign. That's going to cancel, and we're going to be left with -4. This is the remainder. But remember, it says we're going to disregard the remainder. So my slant asymptote is the line y equals x minus 2. So if I think about this line, it has a y-intercept of -2 and a slope of 1. So I'm going to go up 1 over 1. So this is my slant. So it's kind of similar to a horizontal asymptote that it's not absolute, but it's infrequent or uncommon for it to be crossed. So there is my slant. Now we also had a vertical asymptote at x equals -1. Okay, and then we've got 2 x-intercepts. So remember, when I have like a cross or a T, I'm either going to have a graph here and here, or here and here. So my intercept should help with that. So I have an x-intercept at 3, 0 and -2, 0 and a y-intercept of -6. So my graph is going to hug those asymptotes. You could plug in more values if you want, but they're always going to be across from each other anytime I have that x. So these were my x-intercepts and y-intercept. That is enough to get the picture of the graph. Now let's talk about our domain and range. So domain, all reals except for the vertical asymptote of -1, so negative infinity up to -1, and then -1 to infinity. The range is kind of different because it's affected by this horizontal asymptote. And so how we want to write this, sorry, let me switch gears really quick, is we are actually going to write it as all real numbers, because even though I don't touch a value here, I get that same y value right over here. So the slant asymptote really has very little effect on the range. It just kind of structures where the y values are, but eventually we are going to hit every single y value. So we're going to say all real numbers or negative infinity to infinity. Okay, that's it for this video, guys. Thanks for watching.